Welcome for this mathematics lesson. We're going to discuss longitudes and latitudes. The question says, an airplane leaves town A, 83 degrees north, 155 degrees west, to town B, which is 40 degrees north, 25 degrees east, using the shortest route at a speed of 440 knots. Take pi as 22 out of 7 and radius of the earth as 6,370 kilometers. Part A, Roman 1, calculate the distance between town A and B in nautical miles for 2 marks. Therefore, we are calculating the distance between town A and B in nautical miles. And I'll begin to plot, or rather to sketch, the positions of towns A and B. Now, one town is 83 in the north. This is 83 north. Then another one is 40 north. This is 40 north. Those are the latitudes. Then the longitudes are 25 in the east, that is for B, 25 in the east, and 155 in the west. So in the west, we have 155 in the west. It has to be noted that when you move along a great circle such that you are within 2 supplementary longitudes, like 155 and 25 in the east, you usually follow the same path. So if A is hit a point here and B is at a point here, this is where B is, then from A through the shortest route means through the North Pole. So when you go to the North Pole and you go down to B, now it means you are just following the same path. That is a great circle, the same path, because the longitudes of the 2 places are supplementary. When you climb up to the north through 155 west, you will go down through 25 in the east. That is what we call supplementary longitudes. So this means now that it is a great circle, distance along a great circle, when it is in nautical miles, is simply given by 60 multiplied by theta, and in this case, theta is the latitude difference. The angle difference between 155 and 25. 155 and 25. So the angle difference between the 2 places is going to be, let me sketch again here. This is 0 degrees equator. This is the North Pole. So we are moving from 83, this is 83, to the north, then down to 40. So that is the journey now. From 0 degrees equator, then up to a place, assuming that this is the axis of the earth now. This will be 40 degrees, so that we may reach 40 degrees north, where B is. Then this is 83 degrees in the north, so that we may reach where A is. So A is at a point there, and B is at a point here. So this is the arc now. Up to the North Pole, then down to 40. That means we need this angle difference now, this one. So from 180, I'm going to subtract 83 and 40 degrees. This is giving me 57. Therefore, I'm going to use 60 times 57 degrees. This is going to give us a distance of 3420 nautical miles. 3420 nautical miles. The next is calculate the time taken to travel from town A to B. Now, time should be given by distance out of speed, provided the distance is in nautical miles while the speed is in knots. So we're going to use a distance of 3420 out of 450. This is going to give us 7 hours. Then this is a 0.6, which gives us 36 minutes. So this is the time taken for the airplane to move from A to B. We are given further information that from B, the plane flies westwards along the latitude to town C, which is 40 degrees north, 13 degrees in the west. Calculate the distance BC in kilometers. Therefore, in this case now, we are moving from B, then we are going to the west. This is a prime meridian. This is a equator. Now, we were on 40 degrees north and 25 degrees east. But now we want to move from this point, which is B, to another place, which is C. And C is on the same latitude, 40 degrees north, and 13 in the east. That is where C is. This is a 13 in the west. Calculate the distance BC in kilometers. Now, this is distance along a small circle and in kilometers. Distance in kilometers along a small circle is usually given by theta out of 360 multiplied by pi multiplied by 2 r, or rather theta over 362 pi r, the cosine of the latitude. The cosine of the latitude of the two places. That means we're going to have theta, which is the longitude difference from 25 all the way to 13 in the west. When two places are on longitudes which are on opposite sides of the prime meridian, that is the 0 degrees prime meridian or the Greenwich meridian, then we simply add. The angle difference will be 13 plus 25, giving us 38. So we shall use 38 out of 360 times 2 times pi times 6370, the cosine of 40, because the latitude is 40 in this case. So now when we compute this, we shall get the distance in kilometers. 36 or 38, that is, multiplied by 2 multiplied by 22 multiplied by 6370, the cosine of 40 divided by 360 times 7. This is going to give us 3237 kilometers. So that is the distance which is in kilometers between the two places. Part C, we are talking about from town C, the plane took off at 3:10 p.m. towards D, and D is 10 degrees north, 13 west at the same speed. At the same speed. At what time did the plane land at D? So from C, the plane is taking off to D, which is 10 degrees north, 13 in the west. So we are still on 13 west, but now we are going down to another latitude, whereby along this great circle, we will go to 10 now. This is 10 degrees in the north. This means now from C to D, which is somewhere there, we are going along a great circle, along a longitude. That means now, because there is the issue of, again, speed, and the speed of this plane has already been indicated to be in knots. Then for part C, we should be sensitive enough to calculate the distance in nautical miles. So distance in nautical miles along a great circle is usually given by, in nautical miles along a great circle, 60 times theta. So in this case, what we're going to do is 60 times theta. In this case, it will be difference in latitudes. So from 40 north down to 10 in the north, it will be the difference between the two latitudes because they are on the same side of the equator, which is a 0 degrees. This is 0 degrees equator. So from 10 to 40, we have an angle difference of 30. If they were on the opposite sides, of the equator, we could have added. But now it is 40 north and 10 north, so we subtract. When this multiplication is carried out, then we get 1800 nautical miles. Now with distance, we can take the time taken for this journey, which will be distance 1800 out of the same speed. The same speed means 440. 440. Therefore, what we will get now is exactly 4 hours. So from 3:10 p.m., adding 4 hours to this, adding exactly 4 hours, we will find ourselves at 7:10 p.m. the same day. So this will be the time of arrival. We have strictly added the time taken. Because places which are on the same longitude will have equal time. So the time it was 3:10 at C, it was still 3:10 at D. If they were on different longitudes, then we could have taken into account time differences.